Hello. Today we're going to talk about systems of two equations. There's three methods in total we're going to work on, but today we're going to work on the graphing method to solve the system. First, we need to figure out what that means. We need to find one point that exists that both lines share. That's how the solution works. That is the solution of two equations. So we have two equations here. Y equals x minus 2. The second equation would be y equals negative x plus 6. I have a grid ready to graph, and we're going to graph it by hand without using our calculators. We need to look at both equations and figure out where they are on the x and y plane. So for our first equation, we have a slope. Well, the equation is y equals x minus 2. In previous vlogs, we've talked about linear equations and discussed slope and y-intercept. The slope is the coefficient for the x term. So we have x minus 2, the coefficient is 1. Therefore, the slope is 1, as 1 over 1, rise over run. The y-intercept, the point we see here, is 0, comma, negative 2. In our equation, you see negative 2, and that's the b we use in y equals mx plus b. So now we'll graph this line with that information. Now, before we graph, we have to label our axes, x and y, and label our scale. For now, I'm going to use a scale of 1, 2, 3 and on the x-axis, and then 1, 2, and 3 on the y-axis. As you can see, I labeled my x-axis and my y-axis, and I marked 1 and 1 for each axis. And that's enough. That communicates to me that we're counting by ones, both on the x and the y-axes. If you would like to label more, you can label 1, 2, and 3, and 4, negative 1, 2, 3, 4 on both axes if you'd like to. It doesn't harm. But for me, saving time, and this communicates everything clearly. Now we're going to label the y-intercept, and then we're going to use the slope to figure out where the line is going to go. And now, the red line here is the graph of the first equation, y equals x minus 2. That's our first line. And as you saw, when I was counting my slope, it was 1 up, 1 right, 1 up, 1 right. And in previous vlogs, we talked about our rise over run being our slope. Now, we need to look at our second equation and identify our slope in that equation, and as well as our y-intercept. You'll notice two things. Our slope is -1. What that means is the fraction would be -1/1. It would be 1 down and 1 right. Now our y-intercept, you can see I abbreviated y-int. That's our y-intercept, 0, +6. Now I'm going to draw this line on the graph. Now you can see we have two lines, one red line, and one green line, and they cross at a specific place. That place where they cross, that point, is the solution to both equations. That's the answer we need. Let's figure out what the y value and x value is for this point. So this point, 4, 2, the ordered pair, will work in both equations at the same time, simultaneously. This is the answer for the system of our two equations. Now, I can check this answer, and how I do that would be to replace the x variable and the y variable in both equations with these two numbers, 4, 2. Now, using color to make it a little more clear, I replaced my x with 4 and my y with 2. Now I need to see if this yields a true value. If this statement is true, then that means this point, this pair, is a solution for that equation. So that works out. Now you can see that I'm pretty careful. I replaced 4 where x was, but understand there's a negative there. I have to keep the negative. It doesn't become positive 4. It's negative 4 plus 6. So the answer, the ordered pair 4, comma 2, works in both equations at the same time. This is the solution for our system of two equations. Thank you, and I'll see you next vlog. Bye-bye.